Okay, so for your final review, there are basically 6 pages and it reviews everything you've done this year in algebra. Okay, so the first 2 pages, we're going to start with that one, and then we'll hit page 3 and 4. So your notes should be out for the final review notes. Okay, so the very first one, this is a proportion. Now there's lots of different ways to solve proportions, but the easiest way is to cross multiply. So we need to take the top of one times the bottom of another, so that gives us 2 times x, and then the bottom and the top, and that equals 15. Okay, once you're there, then you're just solving it. So we're going to divide by 2. 15 does not divide by 2 evenly, so that gives us 15 halves. So you'd want to leave the answer like that, or 2 goes into 15 7 times and 1 is left over. So either of those answers is correct. So then when we look at the next one, that involves an absolute value. So remember, absolute value is the distance a number is from 0. So the absolute value of 3, that means is 3, but the absolute value of negative 3, is also 3. So the inside could be positive or negative. So we need 2 cases. So the first case for this one would be 3x minus 2 equals 5. So the inside can be positive. And the other case would be 3x minus 2 equals negative 5 without the absolute value bars. So once you're there, it's just solving. So we're going to add 2. We get 3x is equal to 7. Divide by 3. We get x to be 7/3, or again, you can write it as a mixed number. 3 goes into 7 twice, and 1 is left over. So there would be your answer for that one. This one, we would add 2. We get 3x is equal to negative 3. Divide by 3, and we get x to be negative 1. So there would be your 2 answers. So each absolute value should have 2 answers. If you put those in, absolute value of 3 times 7/3, minus 2, this gives you the absolute value of 3 times 7/3 is 7, minus 2, absolute value of 5, which is 5. For this one, absolute value of 3 times negative 1 minus 2 gives us the absolute value of negative 3 minus 2, which is the absolute value of negative 5, which is 5. So it works in that case. All right, the next thing is just some reminders for linear equations. So for linear equations, we've got a linear equation is any equation that you can get into that form. So if you can get an equation in that form, it's linear. It does not have to have an x, so it can be y equals 3. It can be, as long as you can get y alone and your x value has no exponents, it's a linear equation. No exponents, that's what I was just saying. As long as, if you have an x, there's no exponent, then it's linear. And then you cannot divide by variables, okay? So if you can get y alone and you have no exponents, no divided by variables, then it would be a linear equation. So then the next part we're going to review is how to write an equation in slope-intercept form. So slope-intercept form, that is the y equals mx plus b, okay? So in order to write an equation in that form, you need to know slope and you need to know b. Okay, so this one is giving us 2 points. So if they're giving us 2 points, we need to find slope. Slope is y minus y, so y minus y divided by x minus x. This gives me 1 over negative 3. So there's my slope. So my slope is negative 1/3. So now you can either start with this equation or you can start with point slope. I'm going to start with that equation. So we have the equation y equals mx plus b. I just found slope to be negative 1/3. Now I have to find b, which means I have to use an x and a y. So I'm going to use this x and y. You can use the other one if you want. Y is 3, x is 1. So I get 3 is equal to negative 1/3 plus b. So then when I add 1/3 to solve for b, you get 3 and 1/3 is b. 10/3 also works. So your equation would be y equals the slope I just found, negative 1/3 x, plus the b I just found. Your y and your x have to be in there, so be careful with that. All right, so the next one gives you through the point, and it gives you slope. So this one already gives you slope, so now it's easier than this one. So again, I can start with slope-intercept form, or I could start with point slope. If I start with slope-intercept form, your y is 6, your slope is 4, your x is 5. So I get 6 is equal to 20 plus b. If I subtract 20, I get negative 14 for b. So my equation would be y equals 4x minus 14. Now the other option is to use slope or point slope form, and that would be this one. Okay, so if you're going to use this one, it'd be y minus my y equals slope x minus x. So I get y minus 6 is equal to 4x minus 20, and if I add 6, I get y is equal to 4x minus 14. Same exact thing. Does not matter which form you start with. To review some information for page 3 and 4 of the final review. So first, find the slope-intercept form of the line that passes through the given point and is parallel to the given equation. So first thing you need to remember, slope-intercept form of an equation is y equals mx plus b. Doesn't mean you have to start with that, but that's your final. The other thing you have to remember is that parallel lines have the same slope. So your first step is find your slope. So in order to find slope of this given line, you've got 3x plus 4y equals 10. So to find the slope, you would subtract 3x. So you get 4y is equal to negative 3x plus 10. And then we would divide everything by 4. So we get y is equal to negative 3/4 x plus 10 divided by 4. So your current slope is negative 3/4. Now if it's parallel, so parallel slopes have the same slope. So that means your new slope would be still negative 4ths. If it was perpendicular, then your slope would be positive 4/3. Okay, so now you can either start with point slope form, so y minus y equals mx minus x1, or you can start with y equals mx plus b. Doesn't really matter. If you start with this one, you're using your new slope and the given point. So y minus y1 equals my slope, x minus x1. So you get y minus 5 is equal to negative 3/4 x. This is going to be plus a positive, so you end up with negative 6/4. Add 5. You get y is equal to negative 3/4 x plus 7/2. You can also write 3.5, just don't write decimals. If you use slope-intercept form, your y value is 5, your slope is negative 3/4, your x value is negative 2, plus b, so you get 5 is equal to 6/4 plus b. So if you subtract 6/4, you'll get b to be 7/2, then you just have to put it back into the equation form. So it doesn't really matter which one you start with as long as you end up with that one. So next problem, number 2, wants you to solve. So one thing you have to remember with absolute value, there are always 2 answers. So no matter what, you are always going to get 2 answers. So your first answer is exactly what's written, but without the absolute value bar. So 3x plus 1 has to be less than 4. The second one is the inside 3x plus 1. Instead of 4, it's negative 4, and when you switch signs, your inequality switches. So if you can get that part, the rest is relatively easy. So you subtract 1, you get 3x is less than 3, divide by 3, you get x is less than 1. So there's your first solution. This one you subtract 1, you get 3x is greater than negative 5, divide by 3, and we get x is greater than negative 5/3. So absolute values will always have 2 answers, even if it's 3x plus 1 equals 4, absolute value. You'd have 3x plus 1 is 4, and you'd have 3x plus 1 equals negative 4. So make sure you're careful with that. Next 2 deal with elimination. So elimination was where you can add or subtract to make a variable go away. So when you're given 2 equations, 6x minus 2y equals 1, 10x minus 2y equals 5. So your first step is to ask yourself, if I add or subtract right now, will I get a variable to go away? The answer is yes, I can subtract. Negative 2 minus negative 2 will give me 0. So now we actually subtract. 6x minus 10x is negative 4x. Negative 2y minus negative 2y is 0. 1 minus 5, negative 4. Divide by negative 4, we get x to be 1. We are solving the system, which means we need an x and a y. So now you need to find y, and you can use either equation. It doesn't matter. I'm going to use the top one. So 6 times x minus 2y equals 1. So we subtract 6. We get negative 2y is equal to negative 5. Divide by negative 2, and we get y to be 5 halves. And then we write them as ordered pairs. So 1, comma, 5 halves. So there would be your answer for number 3. For number 4, you can't add or subtract right now to make a variable go away, but we can multiply both equations or one equations by any number other than 0. So we could get the x's to both be the same or the y's, it doesn't matter. The y's to be the same, we'd have to get them both to be 15. So we would multiply the top by 5 and the bottom by 3. So when you do that, you get 40x plus 15y equals 20. Bottom equation, negative 21x plus 15y, equals negative 102. So then we can subtract. 40 minus negative 21 is 61x. 15y minus 15y is 0. 20 minus negative 102 is 122. Divide by 61 and we get x to be 2. And then we do the same thing. We use one of the equations to solve for y. I'm going to use the top one. So 8 times 2 plus 3y is equal to 4. Subtract 16. We get 3y is equal to 12. Divide by 3 and y is equal to 4. So your ordered pair is 2, 4. So the next two are from chapters 5 and 6. So they are graphing the system. So the first one is the system of inequalities, and actually we're going to do the summer 6 first. So we have two equations to graph. So you've got x minus 2y equals 2, and we have 3y plus 2x equals 9. You can graph it any way you want. Easiest way is to get y alone. So subtract x. You're left with negative y is equal to negative x plus 2. Divide everything by negative 1. Y equals x minus 2. So your y-intercept is negative 2. Your slope is 1. So y-intercept is negative 2. Slope is 1. So up 1, right 1. Up 1, right 1. And we go from there. A little bit easier to just keep going. Okay, so there's my top equation. And then this one, same thing. You'd subtract 2x. You get 3y is equal to negative 2x plus 9. Divide everything by 3. Y is equal to negative 2/3 x plus 3. So your y-intercept is 3. Your slope is negative 2/3. So down 2, right 3. So down 2, right 3. Down 2, right 3. So there's that one. So you've graphed it. Your solution is where they intersect. 3, 1. So the biggest thing people forget is to actually write the solution, which in this case is 3-1. So let's go back to number 5. So the difference between number 5 and number 6 is number 5 has an inequality. Kind of the same way. So we're going to look at each one separately. So y bigger than 2x plus 1. It's already set up nice. So we're going to first graph the boundary, which is the same thing but with equals. So your y-intercept is at 1. Your slope is negative 2. So that it's down 2, right 1. And because it is greater than, it's a dashed line. And then you pick a point not in the line, 0, 0 is a point not in the line, to test in the original inequality. So if I put 0, 0 in, I get 0 is greater than 2 times 0 plus 1. You get 0 is greater than 1. 0 is not greater than 1. So that means right here where 0, 0 is false, so I shade the true side. And then the second equation is y less than or equal x plus 3. Set up nice for us. Our y-intercept is 3. I'll do it in different colors so you can see it easier. 1, 2, there's your y-intercept of 3. Your slope is 1, so up 1, right 1. And this one should be solid. And then we're going to do the same thing. Pick a point that's not on the line. That would be 0, 0. So if I put 0, 0 into my original inequality, 0 is less than or equal to 0 plus 3. You get 0 is less than or equal to 3, which it is, so this one is shaded below. And then your answer is to darken where they are both shaded. So they are both shaded in this region. So my actual answer is this right here. So the other option would be to erase the other ones, because technically you only want the one shaded. So make sure you darken it. Don't just assume that I know. Make sure you darken it. So 5 has shading, 6 does not. And then the last one is solving. These are from chapter 7. So the way to solve these is to get your bases to both be the same, and it's always going to be the smaller base. So this is already 6 raised to the x minus 4. So I need to ask myself, can I write 1296 as a base of 6? So we know it's not 36, and so even if you don't know what it is, you keep going. It's not 6 to the third. 6 to the fourth is the same as 1296. So now that your bases are the same, we can set our exponents equal to each other. So x minus 4 has to equal 4. We add 4 and you get x to be 8. So the key is being able to change the bases. So it's always going to be the smaller base that you're going to change.